Hello everyone. In this video, you will learn how AXI DMA writes information into DDR memory. You will be shown how to configure the DDR block diagram in Vivado. After the block diagram is complete, we will demonstrate a real-time example of data being written into DDR on the FPGA. In the previous video, you learned how to read information from DDR using DMA. You were also shown how to build the complete block diagram and how each block works. In this video, we are going to reuse the block diagram from the previous lesson. So if you have not watched the previous video, it is highly recommended that you watch it first before watching this video. Alright, so let's get started. So in this video, we only need to make 3 changes to the block design from the previous video. These 3 changes will allow us to write into DDR memory instead of reading from it. So the first change is to the settings of the DMA block. Since we are only focusing on DDR writes, we only need to enable the write channel. After making the changes to the settings, the ports on the DMA block will change. The table below summarizes how to connect the ports in the block diagram. The second change is to replace the receiver IP block with the transmitter IP block. The transmitter IP block generates the data that will be written into DDR. The MicroBlaze processor sends an AXI 4-Lite write command through the S-AXI interface. When the correct command is received, the IP sends 16 pre-initialized values through its M-axis AXI 4 stream interface. The AXI DMA then receives this stream and writes the values into DDR. The table below summarizes how to connect the ports in the block diagram. The last change is to add in another AXI clock converter block. The AXI clock converter's only purpose is to allow the MicroBlaze AXI interconnect, which runs on the system clock, to communicate with the transmitter IP, which runs on the MIG UI clock. Before showing the demonstration, let's quickly review a few things that should be done after completing the block diagram. First, validate the design. If Vivado reports any unassigned addresses, click Yes to assign them automatically. After the design has been validated with no errors, open the address editor and take note of the assigned addresses. In particular, write down the address assigned to the transmitter IP. Next, return to the block diagram and set the X parameter equal to the address assigned to the transmitter IP. The X parameter specifies the address that Vitis must write to, while the Y parameter specifies the value that must be written. To begin the transmission of the 16 pre-stored values, the processor must write the correct value to the correct address. Therefore, X determines the correct address, and Y determines the correct value. Finally, make sure that the UART and system clock pins have been made external and verify that all connections are correct. Here is a brief scan of the completed block diagram. So, when we run our code in Vitis, the processor will first manually write 16 zeros into DDR memory. The processor will then read those 16 DDR locations and print out their contents through UART. If all 16 values appear as 0, then we know that the locations in memory were cleared correctly. Next, the processor will configure the DMA by giving it the DDR destination address, the transfer length, and the command that starts the write transfer. After that, the processor will send a write command to the transmitter IP. This causes the transmitter IP to send 16 values into the DMA as an AXI 4 stream. The DMA will then write those 16 values into DDR memory. Once the transfer has finished, the processor will read the same values from memory again and print their contents through UART. If the values from the transmitter IP were printed in the UART terminal, Then we know that the DMA was able to write into DDR correctly. So this is the Vitis demonstration with the provided demonstration code pasted in. I have already generated the bitstream, exported the hardware, programmed the device, set up the run configuration, and opened the serial terminal. I will not show how to do those steps again because they have already been covered throughout the previous lessons. When we run the code, we can see the output appear in the serial terminal. As you can see, before the DMA transfer, all 16 DDR locations contain zeros. After the transfer is complete, the same locations contain the 16 pre-initialized values from 10 to 25. This confirms that the values stored in the transmitter IP block were successfully written into DDR memory. If the provided code is not working for you, then it's probably because Vivado automatically assigned different addresses to the IP blocks. To see exactly what addresses were assigned, go to the X parameters file. The X parameters file will tell you exactly what addresses are being used. After looking at the X parameters file, you can change the provided code to use the correct addresses. If you have watched this video and the previous video, you should now feel comfortable adding DDR memory to your FPGA projects. You should also feel confident in taking your custom Verilog modules and making them compatible with AXI Lite or AXI Stream. This allows your custom logic to communicate with the processor and other IP blocks. In the next few videos, we are going to cover how to make the MicroBlaze processor handle interrupts correctly. Also, if there is a specific topic that you would like to see covered, be sure to mention it in the comments. Alright, thanks for watching, and I look forward to seeing you in the next video.